When the force that binds us gets a tiny bit stronger, but everything starts to break, it sounds insignificant. A 1% increase in gravity. That's barely more than a rounding error. The kind of change you'd expect only a supercomputer to notice. You'd still drop your keys, and they'd still hit the floor. You'd still walk, run, and jump, barely feeling the difference at first. But gravity isn't just any force, it's the architect of the universe. The silent sculptor that builds planets, shapes stars, keeps moons in orbit, and pulls galaxies into spirals. It holds your body together, your atmosphere in place, your oceans down on Earth's crust. So when it increases, even by a whisper, everything feels it, and nothing remains unchanged. At first, the effects are subtle. You feel just a little heavier getting out of bed. Maybe your knees ache slightly more. Your morning jog takes more effort. Your coffee feels denser in the mug. Flights become slightly more expensive as planes burn more fuel to climb. Engineers notice small, strange stress signatures on bridges and skyscrapers. Nothing dramatic, but enough to raise eyebrows. But that's just the surface. Deep underground, where gravity's gentle pull becomes weight in megatons, pressure begins to rise. Tectonic plates grind harder. Magma chambers swell faster. Fault lines already holding back centuries of tension are pushed beyond their limits. Within weeks, earthquakes become more frequent. Volcanoes flare up with less provocation. The Earth groans under the subtle shift in weight it was never designed to bear. In the oceans, gravity's hand is just as relentless. Sea levels don't rise, but water gets heavier. Tidal forces intensify as the moon's pull acts on denser masses. Currents shift. Storm surges grow higher. The kinetic energy of waves increases, eroding coastlines faster than before. Shipping routes must adapt. Buoys read higher wave amplitudes. Storms gather strength more easily, fueled by slightly more aggressive sea motion. Tsunamis, once rare disasters, become more common from increased seismic activity, and now they carry more mass, more devastation. On land, gravity's extra percent begins to take its toll on biology. Animals bred for speed and agility suffer joint damage. Birds must flap harder to maintain altitude. Insects with delicate wing structures can no longer fly at all. Trees begin to grow differently, shorter, more robust, with thicker trunks to withstand the extra gravitational pressure on their vascular systems. And humans, we start to feel it in our bone. The skeleton, calibrated by evolution for one specific gravitational constant, now carries more stress. Cartilage wears faster. Elderly populations see a spike in fractures. Obesity becomes more dangerous as weight gains literal new meaning. Athletes hit performance plateau. Space agencies rush to recalibrate every system based on new weight-to-thrust ratios. Every stair feels one step higher. Every fall hits harder. Every life is quietly heavier. But perhaps the most alarming changes happen not on Earth but above. Satellites orbiting with precise velocity and altitude to maintain their balance now feel a stronger pull. Their orbits decay faster. Dozens of low-orbit systems begin to drift. GPS becomes unreliable. Communications weaken. Space debris starts to fall more frequently, lighting up the sky in unpredictable firestorms. The International Space Station must fire its thrusters more often to stay afloat. Eventually, it may need to be abandoned. Future missions to space require more fuel, more thrust, more time, and more risk. Escaping Earth's grip just became harder, permanently. The dream of colonizing Mars, set back by decades. And time, yes, time is also affected. According to general relativity, stronger gravity slows time. Not enough to notice daily, but atomic clocks start to drift ever so slightly. Over decades, timekeeping systems require new corrections. Long-term experiments must account for relativistic anomalies. We age the same, but the instruments by which we measure change must adapt. The world continues, but not quite in sync with the one we once knew. And all this, from a 1% change, a force just slightly stronger, a weight just slightly heavier, a planet still spinning but under new pressure. So what if gravity increased by just 1%? We'd survive, but we'd know. It would humble engineers, challenge biologists, pressure infrastructure, alter climate, reshape evolution, and remind us that every constant we depend on is a silent miracle. Because sometimes the most terrifying force in the universe isn't what changes over, it's what changes just a little and never stops.